This is the solution to problem number 45 from homework 6.4 day 3. We're asked to graph sine function y equals 2 minus sine of 2 pi x divided by 3. I'm going to rewrite this in the form that we more typically see. So I'm going to say negative sine of 2 pi x over 3 plus 2. And now let's go through the analysis like we did in class. So the first thing I want to find out is where is that axis of oscillation? And here we see that the graph is shifted up 2 units, or the d value is 2. So our axis of oscillation is going to be at y equals 2. The next thing I want to know is what's the amplitude? So the amplitude comes from this leading coefficient in front of the sine, and that is -1. Amplitude's always positive. So we have an amplitude of 1. So that means this graph is going to go up 1 unit and down 1 unit relative to the axis. So I'm going to axis of oscillation. I'm going to put those on my graph. So I'm going to put 1, 2, 3. I'm going to do each one of these red lines is 1 unit. And then I'm going to sketch in the axis of oscillation, which is at y equals 2. So that's the axis of oscillation at y equals 2. And then from there, our graph goes up 1 to the maximum and down 1 to the minimum. So I'm going to sketch in lines at y equals 1 and y equals 3. The next thing I'd like to determine is the period. And the period's going to help us to set up our x scale. So the period for a sine function is always 2 pi over the b value. Here, the b value is 2 pi divided by 3. So I have 2 pi over 1. I'm going to multiply by the reciprocal, which is 3 over 2 pi. The 2 pi's cancel, so my period is 3. Key points on a sine function occur at intervals of 1/4 of the period. So 1/4 times the period, which in this case is 1/4 times 3. So I'm going to have key points every 3/4. So our x scale is not going to be in terms of multiples of pi, but instead just in terms of 3/4, in multiples of 3/4. Next thing we want to know is our starting point. So for the starting point, we're going to transform an easy point. This is a sine function. So sine of x, the starting point for that is 0, 0. And then we're going to see what transformations apply for this function. So what's happening to x values? This 2 pi over 3 means we're actually going to multiply x values by this reciprocal, which is 3 over 2 pi. So 0 times 3 over 2 pi is still 0. So 0, 0. That's the only thing that's happening to x values. And then let's see what's happening to y values. Y values are going to be multiplied by -1. So times -1. So becomes 0, 0, still stays at 0, 0. And then we're going to be adding 2. This plus 2 means we add 2 to y values. So our starting point is at 0, 2. The last thing we need to consider, since this is a sine function and we're going to be starting at the axis of oscillation, is does this start going down as we move to the right or up? So this is a reflected sine function, so we're going to start going down as we move to the right, because this is a reflected sine graph. Okay, so let's put on our scale. So on the x-axis, I'm going to count by units of 3/4. I'm going to make it as easy for myself as I can. So 3/4, 2 times 3/4 is 6/4, which I can write as 3/2. And then I add another 3/4, so that's going to be 3 times 3/4, which is 9/4. You can use decimals too if you want. You could write this as 1.5 if you wanted. 9/4. I'm going to add another 3/4 to that. So 9/4 plus 3/4 is 12/4, which is 3. Then I'm going to add another 3/4 to that. So I had 12/4 plus 3/4 is 15/4. And add another 3/4 to that. I'll have 18/4, which is the same thing as 9/2. And then I'll mark off some values in the negative direction. So -3/4, -3/2, -9/4, -3. And now let's start plotting some points. So our starting point again was here, 0, 2. And for sine, we should be starting at the midline or at the axis of oscillation. And then we're going to start going down once again because this is a reflected sine graph. It's reflected in the x-axis. And we're going to have a key point every 3/4, which is how we set up our x scale. So we're going to have a point at 3/4, 1. We're going to have a point at 3/2, 2. We're going to go up 9/4, 3 at the maximum. Then another 3/4 is going to be at 3, 2, 15/4, 1, etc. So I'm going to continue to put points on my graph where every 3/4 of a unit on the x-axis I have a key point, either something crossing the axis of oscillation, a maximum, or a minimum value. Then I'm going to connect these with a nice smooth curve using arrows appropriately to show that it continues on forever.